We're now live, and now I'm gonna let everyone in. Okay. All right, so we'll start in 2 minutes, just because I noticed more people are coming in. It's very silent. All right. Okay, I'll give it 1 more minute and then we can start. Since we did change links, so probably people are joining again.
On a changé le lien.
All right, I think we can start now. So good morning, good evening, good afternoon. I don't know where you are in the world, so good wherever you are. Here we're in Paris, and joining me in the same room actually as me are my co-organizers, Sarah. And I'm looking at her, but you cannot see her, but I'm sure she's here somewhere. And Marine here at SoftBank Robotics. We're in Paris, so good afternoon from us. Also joining us all the way from Colorado, our 2 organizers as well, Akib and Brad. I guess good morning to you guys. The day has just started. And Amit is supposed to be in Hong Kong, but given the pandemic, he's actually here in Europe. So I would have said good evening, but good afternoon. And as for me, I introduced everyone but myself. So my name is Karen Tatarian. I'm a robotics researcher here at SoftBank Robotics in Europe, and I'm also a PhD student, doctoral student in Sorbonne University as part of a Marie Curie project called Animatas. And I want to welcome you all to the first edition of this workshop. And a little story behind why we started it. Back in November 2019, we actually hosted a winter school on applying research in the industry here in our headquarters in Paris. And the idea started was that because we had so many researchers either from industry or academia, and we noticed that actually we work and we're trying to solve very similar problems. However, sometimes it feels like we're on 2 separate islands and the bridge sometimes disconnects. And so we wanted to create a community where we can actually come together and we can discuss relevant research that's taking place. So in either side, so that we can advance the field of social robotics, and we can only do so by being present. And we have realized that sometimes even in the industry, we conduct certain research that not necessarily goes into publication, but it's also just as important to discuss these these technologies that we're researching. And so this is it. This is what led us here. And I hope that in today In the panel discussion, we would be able to hear more from you, so I would get to know you better. And on Thursday as well, during the breakout room session, which was an idea that we initiated in order to get to know you better. I wish we would have all been in Naples, really honestly, given the weather here in Paris. But it is what it is. And virtual means that more of you can join us, which means we can get to know more of you and have even maybe more in-depth discussions. So I'm going to stop talking and I'm going to give the floor to our very first keynote speaker, Alessandra Sciutti, who is here joining us all the way from Genoa, Italy. Alessandra is a tenure track researcher and a principal investigator at the Istituto Italiano di Tecnologia. Excuse my non-Italian accent. And Alessandra obtained her PhD with a focus in humanoid technologies from the University of Genoa and IIT. After a period, she worked as an assistant professor in the bioengineering department at the University of Genoa, which is also affiliated with IIT. She is now working at IIT. In July 2018, she was awarded the ERC Starting Grant Whisper on the investigation of human shared perception with robots. And since March 2019, she has been a tenure track researcher, principal investigator of cognitive architecture, for collaborative technologies, Contact at IIT. And today she will be giving us the first keynote speech, which is on towards social intelligence, which is actually, it falls right in place because we actually had one of the questions that in the forums that we posted on the webpage where people were asking questions they wanted to discuss during the workshop. And one of them is, what is social intelligence? So I think you are the perfect person to answer that question in your presentation. So I will leave the floor to you, Alessandra.
Thank you, Karen, for your nice presentation. And I'm going to share the screen. Let me see if this is visible for you. And okay, so I'll hide the video. Thank you very much for your kind introduction. And I hope I will be the right person to talk about this ideal path towards social intelligence. Let's start from the fact that we have already robots in our lives. They're already part of our everyday life in some sense, but behind the scenes, because since 1950s, they are building our cars, they're building our pieces of electronics. They are really working for us in places where we cannot see them. So in industries, very far away in space, exploring new planets, and maybe closer to us, but in place where we don't want to be. So maybe monitoring dangerous location or helping us in emergency scenarios. So that's it. Robots are among us, but more recently, let's say in the last few decades, a desire or the feeling that we needed also a stricter interaction with them, also, let's say, a social component of their activities became more present in, everyday discussion on the newspapers. And most of all, because I believe we realized that a lot of the activities that they did, also that the robots already did, were not as perfect as if they were done in collaboration with us. So we rediscovered that even activities like industrial application have a social component in the human society. And so a lot of interest emerged and is still emerging about this idea of cobots, robots that work in industry, but helping humans in strict collaboration, or at least next to humans. And there is very much interest in that. even for robots in space. So now robots in space are not seen only as alone in space, commanded from far away from Earth, but rather as support. So interacting with humans to support their interaction with space or the spaceship. And even in the emergency scenarios, the pandemic also helped us to understand that a social dimension is important for us. So it is not enough, it's good, but it is not enough to have robots that can bring medicines to the patient where the medical doctor cannot enter. At least it would be ideal if it could convey, be a medium for a sort of social interaction between the patient alone and other humans. So we want or we need for let's say exploiting at best our interaction with the robot, even in those fields that traditionally were considered, let's say, interaction with the environment based, also a component of interaction with a human, a social component. Plus, there are a lot of other activities in which this social component would be even more necessary. Let's consider assistive and rehabilitative robotics, both on the physical and the social domain. Let's consider those attempts of using robots or interacting with robots while performing arts. Or if we think of the domain of robots for education, which is gaining more and more interest nowadays. The problem is that if on the one hand we have robots that go to space, literally, or that can do very effectively athletic stunts like huge backflips with no problems, then when we pass to investigating or to studying how robots interact with us, sometimes we face failures, unexpected failures. How a robot that can do a backflip cannot realize that a person is wanting to actually shake hands with it. And this problem rises from the fact that we tend, as humans, to consider superficial interaction. So interaction for us is doing actions together. Shaking hands means exactly shaking hands together, performing this act together. Well, it's true, but it's not the whole story. It has much more depth. Because when I move my hand toward you to shake your hands, I'm sending you a message. So my action, per se, just the handing, is a message that you read. And you read that message because, and in order to create a sharing goals, sharing intentions, and before that, sharing perception. And that's where the difficulty arises. So robots are not to blame because they can do that. We humans are a bit to blame because we are the ones who are complicating things so much for these poor machines. But we have delusions of seeing the world for how it is. But that's absolutely not true. Our perception of the world is deformed, is changed by our brain. So it is well known, for instance, in general, that perception is an inference. What I perceive is not just the physical stimulus that it's in front of my eyes, but rather my brain is enriching it. So I take the stimulus, the visual stimulus, and then my brain adds my prior knowledge, my prior experience, maybe my mood. It attaches, it enriches this information. And that leads to perception. This is what brings in illusions. We all know visual illusions where our brain fills the gap of our perception and makes us see something that is different from the mere physical reality. And on top of that, we have a wide range of cognitive biases. So we don't perceive the world as it is, we don't perceive others as they are, but our brain tries and transforms that in a way that sometimes is thought to optimize our perception, to actually facilitate us, help us in understanding more easily or faster what's happening in front of us. And one of I think the clearest example of that is action perception, action understanding. So when I'm moving in front of someone, when I'm observing someone moving, I'm not just seeing the movement. It's not just my visual perception that is involved, but rather in my brain, also the areas that are responsible for my movement are activated. This is what has been discovered with the discovery of the mirror neurons, which means in practice that I'm using my motor knowledge, the models that I've developed to control my movement, to understand, predict the movement and the actions of others. This implies that actions are not actions alone. Movement becomes a form of communication. So if you see this guy, you immediately know that his goal is to pass you an apple, and that's it. But if you see this guy, which is the same guy, well, the same movement, even the same goal if you want, but you realize that there is something wrong. Say, no, I would be more skeptical at eating this new apple because how the movement is performed is telling me something more. This guy is rude toward me, is aggressive. I might have pissed him off sometimes. And interestingly, our brain knows that our actions are a form of communication, and beyond understanding the goal of the action, is actually able to read also the subtle modifications and understand the how of the action. So in this case, it has been recently found indeed that there is a specific part of the brain that understands, that responds differently if an action is performed rudely or gently toward me. But this is just one of the multiple exchange of signals that continuously happen whenever we are interacting with someone. And even if I don't want it to happen, my body is revealing, even in this very moment, a lot of things about myself, my emotional status, my goals, my focus of attention. And even if you don't realize that, your brain is processing all this information all together to create a complete understanding of me and of our interaction. And our goal is to try and, let's say, put a finger on this very complex mechanism that is supporting mutual understanding. And a way to do that is actually to use robots, even though they are still not so socially intelligent as we want them to be, as tools to uncover how these mechanisms unfold. To do that, one possibility that we pursue is that of seeing whether we can make it so that robots can use this very same signal in a proficient way. They can become able to send these implicit signals and read these implicit signals. But that's not easy. Indeed, it's a totally open question of how to do that, how to establish shared perception, mutual understanding, even at the level of affective stimuli. And on that, I would be super happy if some of you have ideas to contribute to the research. We have just recently started this call for a research topic on frontiers on affective shared perception. And because the question for us is still much very open. But what I can do today is just give you a brief summary of some approaches that we have tried to pursue to try to understand at least some of these aspects involved in the interaction. So, for instance, trying to make also the robot action a form of communication as they are in the case of human action. And so if you remember the aggressive and gentle guy, here we try to report the same style of the action onto the robot, asking ourselves, well, can a robot action, a humanoid robot action, be as communicative as the human ones if we pick the right features in the movement? And the answer seems to be yes. So if we ask people to judge the movements of the human and the robot and rate them in terms of, let's say, aggressiveness, kindness, we have very similar ratings. But most importantly, if we look at the neural responses that are evoked by the observation of the robot or the human action in this part of the brain that is sensitive to style, we get very similar results. And what about interaction? Well, if you don't limit yourself to observing someone that is either rude or gentle, but you have to interact with a robot, and this robot moves with different action styles, this has a super evident impact on how the human partners will behave. And so if the robot is rude, the human will start interacting in a more rude way. And versus if it is gentle, the human will be gentler. This means that even very little modifications in the way the robot performs the very same simple actions, and we are not even considering facial expression, just the movement, are more than enough to totally twist, to totally change how the interaction will unfold. And more recently, we have actually investigated that the social behavior that the robot exhibits can have also a positive impact, also in context of motor training, for instance. So we noticed that even in a context of physical motor training, it is possible for the robot to facilitate or at least to increase the motivation during the interaction without hindering the learning. But if you want to know more, I suggest you to tune to Giulia's presentation tomorrow here in the Roman conference. And these are just a few examples. We've seen that actually it is possible to communicate really a lot through the movement of the robot. We can communicate the right action timing, we can communicate the goal, we can even communicate how much effort it takes to perform a certain action. And that's cool, but that's not enough. Of course, we need also the robot to be able to sense the very same signals when a human is moving around. And this is quite a tough task, and we, of course, focused a lot of our research on one of the most communicative signals that we can think of, the gaze. And indeed, we found out that if the robot is able to sense the gaze direction, it can very easily, let's say, infer what the person wants, even if the person is not instructed at all on how to interact with the robot, and even if the robot is sensing just the eye gaze. So it's totally blind to language, it's totally blind to speech, to pointing, to facial expression, just through eye gaze monitoring. In this context, it could understand what to do and when to do it in a very effective way. And more recently, we've seen that we can go further. So even trying to understand from gaze things or information that the person tries to hide. For instance, understanding when the person is experiencing cognitive load because he or she is lying. And it works pretty well, both in, let's say, interrogation-like scenarios and in very short game-like scenarios. So reading these implicit signals can really open a window of understanding of what the human is experiencing during the interaction. And again, I mentioned a few examples about gaze, but we explored also other dimensions like reading facial expression to get an idea of the reaction of participants to robot behavior, and reading movement properties. For instance, we found out that it's very useful and very scalable, the possibility for the robot to understand whether the movement in front of it is biological, so generated by a living being or not. An ability that indeed human newborns have, and that now our ICAB shares with them. And I do believe that there is still a lot more that understanding human motion could bring into the field of human-robot interaction. And we have recently collected the contribution of a large group of authors coming from different perspectives, from the neuroscientific perspective, cognitive science, machine learning and computer vision, and robotics, that joined their effort to try and find how modeling human motion can be useful for these different fields. And if you want to know more, I suggest you to have a look to this book that just recently got printed. You might raise the point that so far I just spoke about not interaction, but interface. So I just spoke about the signals that are exchanged when we are interacting with someone, but it's not a full, real, naturalistic, in the wild interaction. And that's definitely true. It's correct. I do believe that it is very important to understand these basic signals because they represent the building block upon which we build our social intelligence. But still, we are not investigating social intelligence as a whole. And that's a good point. How to deal with this issue? Well, first of all, we should add or change the perspective and trying to see and analyze this entire issue in terms of an architectural view. So understanding the human preference or reading a specific gaze signal can be useful, but is for sure short-lived if that is not seen as an instantiation of an architecture, so of a system that can use this information to build a memory, to predict, that has a motivation that guides the need for exploration and of learning. And switching to this vision, trying to understand which is the necessary cognitive architecture supporting the emergence of social cognition, it's a very difficult question, and we are currently trying to address it with different approaches. For instance, we recently tried to investigate whether a simple motivation mechanism could be used as a way to exploit the emotional information read by the ICAB as a way to personalize and adapt its interaction style to different caregivers. But I point you to the recent paper by Tanesca et al. If you want to know more in detail. The other way, together with the architectural view that I suggest, is to try and run also more explorative experiments. So the experiments that I described in the first part of the presentation are more, let's say, psychophysically inspired. You have a very controlled scenario, you have a very specific and clear hypothetical question, research question, and you can really study a very precise change in behavior. But when you come to more complex construct, let's imagine building the rapport of trust, then I believe that also performing controlled but more explorative experiments could help. And in this respect, we tried with Alex Arroyo to run an experiment in which we investigated whether it is possible over a short period of time to increase the rapport of trust between humans and the robot. And it was a game, it was a treasure hunt in which the robot could provide hints on how to find hidden objects if it were asked. And at the end of the game, to see whether the robot could exploit the trust, the robot suggested participants to gamble. Gamble all they had won. He said, okay, you have won this. If you find another hidden object, you can double your winning. If you don't find it, you lose everything. And I suggest you to gamble. What we noticed is that although all people that participated performed differently, different choices, we noticed an increase in their behavior, showing more and more trust over time. And this was confirmed also by their rating about their trust over the robot. So even a very short interaction, 30 minutes, was enough to show some changes in their rapport with the robot. And in terms of the gambling question, we noticed that all participants who managed to find all the hidden objects decided to gamble, to follow the robot advice, and potentially suggesting also that the suggestion by the ICAB was actually part of their decision in some sense. The interesting point is that even though all participants increase the level of rapport with the robot as measured by, let's say, a standard questionnaire that measures rapport, what we found out is that the ones who followed the advice of the robot, gambled their money, and lost were the ones who had, in the end, a stronger rapport with the robot. Something that was super not expected, at least by me, and also the other researchers. And this result was something that told me that although the experiment was run in a lab, so it was ecologic, but up to a certain point, very limited, very simplistic with respect to the very complex interaction, social interaction that we have every day, it still was able to underline unexpected results and reveal that this phenomena of bonding and of rapport between humans and between human and robot are more complex than sometimes we expect them to be. To summarize, I do believe that the path towards social intelligence is still long in front of us. And I pointed out a few elements that I think will be necessary to move along this path. So understanding how to establish a shared perception between humans and between human and robots, appropriately taking into account the role of embodiment, which is so crucial in the way humans establish interaction with each other, and then try and establish a sort of cognitive architectural view on this question, plus other points that I didn't have the time to expand today. But I do believe it is really crucial to face them, because otherwise the risk is that robots will be adopted by early adopters, by fans, as maybe we are, but they won't be able to fulfill their potential and will end up being set aside as a cool, interesting toy or novelty without becoming really the autonomous interactive agent that we want them to become. The aim, the solution is to create more humane robots, in the sense of robots that are considerate of us as humans, and then start to think, to have models of us that allow them to interact with us as we interact between each other. With that said, I want to thank all the groups of people who are performing the research that I presented so far, and a lot of others that I didn't have the time to present. And I want just to advertise that if you want to continue the discussion beyond this workshop today, in the discussion, the next session of the discussion, you could take part to our workshop, which will be held on the 3rd of September in the afternoon. And with that said, thank you very much.
Thank you so much, Alessandra. I really enjoyed your talk. It was really interesting. And I really enjoy your research work and your studies, and I always try to stay up to date on it. I'm gonna check because we did post a link for Q&A, and I think there must be questions for you there. So I'm gonna try to read as I go. All right, so we have 3 questions there. And for anyone else who still wants to submit their questions, I have shared the link in the chat. So you can go directly there, vote for the questions, and if you don't want to answer, if you don't want to ask, you can vote as well. So, all right, so we have a question is on how did the robot respond when the person lost in the gambling? And they added by saying compassion could explain the higher bond felt by participants.
Okay. That's a good point. We were thinking on a similar line. I have to check exactly which was the wording that was used in response to the performance of the participants. I don't remember it to be compassionate though, but I might be wrong. I will check. On the other hand, the robot that we used was the iCup, which looks like a kid. A boy, if you want. And from some open comments of the participants and from the results, the doubt came to us that participants established a sort of interaction similar to the one that you establish with children when you're playing with them. So as if the child has planned this very nice game, it wanted you to win, then you lost, and then you feel sorry for the robot, for the child, that things went not in the right direction or in the direction in which the child predicted. But we have not a clear answer on that yet. So I will certainly consider the idea of studying whether the feedback that the robot gave could trigger compassion in one of the two cases and not in the other. Thanks.
Yeah, that would be interesting. All right. So I have a question did you try to build a whole model of human virtually based on your knowledge?
Sorry, I don't know if I understood. You mean a virtual human? So to recreate a virtual human?
Yeah, to create the human-robot interaction virtually, I suppose.
Okay, so we use a lot the robot versus the use, let's say, of a virtual agent, even though also in some experiments we are actually using also virtual agents. But let's say the idea of having the robot is in some sense to simplify the question. So if you have to study interaction with a robot and you're doing it virtually, then you have to model the robot, to model the interaction in some sense, and model the environment. And whereas if you have a real robot, you have a lot of drawbacks in terms of the mechanical failure, the complexity in handling the robot. But on the other hand, you have an actual physical agent sharing your space. So you have actually a device that is on which you have control. So you can control exactly how it perceives, how it decides, and how it moves. But at the same time, it is really sharing the space with the agent, with the human, let's say. It can also jointly act on the same environment. And we do believe that this makes an important difference. We initially have some results also in this direction in the study of the style that I was discussing. We are actually comparing a virtual representation of the robot versus a physical representation of the robot. And even if there is no direct contact between the two agents, the fact of being there versus being virtually represented seems to make a significant change in the reaction of participants.
Yes, as you mentioned in the beginning of the presentation, the effect of embodiment on communication, and it's very multimodal as well. So let me check. I think this is the last question I have posted here, and somebody wants to hear your thoughts on development, saying that you did mention that it is an important step, but you did not cover it in the talk. So more on your thoughts on development.
Yes, no, that's totally correct. It would have needed probably another presentation for that at all. Just in summary, what I could say is that we as humans develop our abilities. So we start from very basic skills, but that are already everything we need to learn and develop our complex intelligence, complex social skills. Mm-hmm. And the idea of development is that if we might also have a look at a simpler system that has already per se everything that we need to develop afterwards, that would be maybe a way to facilitate the research, facilitate the understanding of how we become what we become as adults. The idea is that when you're building a system, when a system actually is developed progressively, there are steps that are crucial for the development that then disappear, are not visible anymore at all in the final system. And therefore, sometimes reverse engineering is not the way to go. It's not possible to reverse engineer the final results without knowing the steps that have now disappeared. So looking at how a system develops could open a total different perspective and a wider understanding of why we do what we do, why we are what we are.
Yeah, that's very true. And actually, you're joining us also on the panel discussion. So I think hopefully it will be extremely interactive, because I do love interactive panel discussions. So we'll be hearing more your thoughts in depth on topics related to that. So thank you so much for the presentation, Alessandra.
Thank you very much.
So also, if you have any questions still to Alessandra, please make sure to submit them on Menti, and we'll keep them for the panel discussion. Next, we have a paper that was submitted to this workshop, and the title is Towards Real-World Scenario Perception Enhancement and Emotional Expression in Social Robots, which will be presented by Alessandro Di Fava, and I will let you... all right. Alessandro, can you hear me? Okay.
Hello, yes.
Yes.
This is Alessandro. Hello.
Hello.
Can I share my screen?
Yes, you should be able to. Please let me know if you have any difficulty with that.
Okay, let's share the screen. Can you see my screen?
Yes. Yes, we can.
Okay. So I can start.
Yes.
Okay, thanks. So as you said, yes, this is a paper that, nowadays the robots are becoming closer to the real world scenarios. So in our last robot, we fought to increase and improve the perception, the emotional expression that this kind of robot, especially social robots, they should need to be closer for a better human-robot interaction. We have experience of robots from 2004, and in each robot that we did in our company, in Robotics, we try to improve this kind of human-robot interaction, because we know that to make a robot more acceptable in a real-world scenario, some skills from the robot side are needed. And with our last robot, that is Ari, that we did this year, we try to tackle with this information. Let me present a little Ari. Ari is a high-performance robotic platform that is designed for a wide range of multimodal expressive gestures and behaviors. And this makes Ari an ideal social robot that is suitable for human-robot interaction, perception, cognition, and also navigation. Ari is 100% compatible with ROS, the robotic operating system. And there are some skills that can be shared inside a robot, like deep learning, data analysis for smart cities, and so on. But the main concept that we wanted to stress inside this new robot, that this new social robot is user-centered. This was designed with the user-center in mind, because there are some key considerations that we wanted to focus. And the major goal has been to improve user acceptability of social robots by both operator and user, by making it more human-like when it comes both with the visual appearance, but also behavior, like voice and movement. And for this reason, Ari has been designed to resemble the human body, considering a suitable body-head proportion. And also its covers are 3D printed with the PA12 to obtain a smooth surface to reduce the risk in a human-robot interaction. The platform has been designed and equipped with an audio and expression system whose main goal are to improve these capabilities and engage with the user, encourage the interaction with humans in complex and structured spaces. And the Ari audio has a re-speaker mic array version 0.0 that is an array composed of 4 microphones that can be used to record the audio and process it in order to perform a task like speech recognition. The microphones are positioned far from the motors in the center of the robot to reduce the inner noise during movements. And the covers are, where the microphones are positioned, they have been optimized to have good acoustics. What about the amplifier? For the amplifier, we consider a digital stereo board of 30 watt to make the speakers sound best. We have also designed a special case that provides enough volume for the acoustic waves to be reflected in the frontal direction of the robot. In this regard, it's key to mention that Robotics is participating to a European project Horizon 2020 called Spring, which goal is to develop socially assistive robots with ability to perform multi-person interaction, but with an open and extensive dialogue. So as part of Spring project, PAL has been working a lot in improving the ARI audio architecture. Also, a lot of tests have been conducted at different distances, angle, where the robot is standing or moving, to evaluate the audio quality. To improve, for improved reverberation, the array has been placed, the microphone array has been placed on the belly of the robot, having made a circular gap to insert it. And about the robot expression system, its expression system enriches the non-verbal interaction by facilitating the establishment of joint attention between human, robot, and also showing some interest and emotion that responding to the human partner. So this will improve the human understanding of the robot, making it more predictable, increasing the acceptability and also the trust. To do this, ARI was designed with LCD eyes with animation, supported by movement of the head, combined with the slender arms, so to offer the option to show expressive and human-like gesture, combined with the facial and prosodic feature to reach the interaction. And to reach more this system, ARI can display also a changing of LED colors on the ears and the back torso to give extra information. Just to have a brief conclusion, the ARI robot was conceived as a social robot, including a wide range of multimodal expressive gestures, gaze, and personalized behavior, with a great potential to become part of the real-world community by applying also AI algorithm as well. Future work with ARI and EU project like Spring will be validating the real user, to validating the robot with the real user, especially to improve the human-robot interface, to have a social robot, letting them be more accessible in the real-world scenario. And for me, that's it. I don't know if you have any question.
Karan, your mic is off.
Okay, so now I guess you can hear me. Thank you so much. I was saying thank you so much for your presentation, and I guess you have a few questions that were posted on Menti. So you have 3 questions. The first one is, you said that you increased the human likeliness of the voice. What features did you add to do so? Alessandro?
Yes, yeah, sorry, I put I muted my microphone.
Yeah,
yes, we did a kind of a crossing improvements between the design, where to put the sensor, also the cover, the covers that they were done in the way to improve, to avoid, to improve the quality of the audio, also to avoid to be too close to the motors. So it was a mix of a lot of features that we introduced.
Okay, and I guess we have another question related also to audio, and it is the following. The microphones are only on the front of the robot. If so, how do you handle situations like group discussion or someone calling the robot from behind?
This is a good question. This is also one of our goals that we want to test in the future work, and especially in the Spring project, because from this we can understand if we have to change something in the design, or because we don't want to make also a robot that will be so expensive to have like a sensor all around. So from this further test, we want to understand which can be a better strategy.
Okay. Speaking of expensive, just out of curiosity, how much does the ARI robot cost at the moment?
With this robot, to be also more to allow the robot to be more present inside the real world scenario, we pushed to have a cheaper robot. So this goes from 20K up.
Okay. Okay, I have one question that actually I'm very interested in, because I got the chance to
Okay.
ARI back in November at the ICSR conference, back when it was physical conferences. And I got the chance, actually, there was the demo where you could shake the hand of ARI, and actually
Yes.
ARI is my height, so it was cute, it was cool. And the question is, in the handshaking of ARI, is there tactile sensors on the hand? So does it feel the pressure or the hand when it's shaking?
Not right now, no. We are studying, this is also a good question, because we are studying right now this solution, but for another robot that we have is Tiago, because we want to improve the manipulation, the perception of the tactile. But maybe once that the solution will be closer, maybe we can easily integrate also in ARI to have a improved version of this also handshake and feedback with the humans.
Okay, it's actually very interesting that the question is on tactile sensors, because after in 5 minutes we're going to have Dr. Mohsen, who is from BMW Group, who is also going to present on human robot interaction, but through tactile sensors. I suppose we can take a 2-minute break, and we'll be back again with our next keynote speaker. Okay.
Thank you.
Thank you.